In this video I'm going to be looking at the solution to question 3 of the June 2010 Edexcel FP1 paper. The topic of the question is numerical solution of equations. The question starts by giving us a function f of x equal to x cubed minus 7 over x plus 2, and we're asked in part A to show that there is a root of f of x equal to 0 between 1.4 and 1.5. Having done that, in the second part of the question we're asked to use interval bisection twice to reduce the size of the interval containing that value alpha to 0.025. And then finally, in the third part of the question, starting with the value for 1.45, we're to use Newton-Raphson to calculate a second approximation, giving our answer to 3 decimal places. So the first part of the question then says simply show that there is a root between 1.4 and 1.5. So what we must do is find the value at 1.4, which turns out to be negative 0.256, and the value at 1.5, which is equal to 0.708. So the first value there was less than 0 and the second value greater than 0. So we can state then that the change of sign implies that there is a root in the interval 1.4 to 1.5. So using standard notation there for the interval. It's important that you say that the change of sign implies that. So 2 marks, a method mark for getting both of these values evaluated, and then an A mark for this statement, giving us the 2 marks for that part of the question. In the second part of the question, we're starting off with that interval 1.4 to 1.5 and asked to reduce it in size, so using interval bisection. So the first point that we now need to calculate is the value at 1.45, and that turns out to be 0.2210. Obviously this is greater than 0, so now our root is in the interval from 1.4 up to 1.45. That's where the change of sign occurs. So checking the halfway point of that one then, f of 1.425, this turns out to be negative this time, 0.018, negative 0.018. The important thing is that it's negative. So now we have a root in the interval from 1.425, where it was negative, up to 1.45, where it was positive. 3 marks for that part of the question, a method mark for finding the midpoint there using the midpoint, a second method mark for again getting the midpoint 1.425, and an A mark which is given as correct solution only, so any errors here are going to lose that A mark. 3 marks for that part of the question. Part C is using the Newton-Raphson equation. So remember that the Newton-Raphson involves us first of all differentiating, so we need to find f dashed x, and f dashed x is equal to 3x squared and then plus 7 over x squared. So that's the derivative. We're starting off with the first point at being at 1.45, so Newton-Raphson will tell us that the next value x1 is equal to x0, our starting point, minus f of x0 divided by f dashed of x0. So we need the values of f of 1.45 and f dashed 1.45. So we have 1.45, that's our starting point, minus, well, f of 1.45 from the first part of the question was 0.2210, and f dashed of 1.45 is equal to 9.6368. It doesn't matter how many figures you use here. You may do it algebraically to start off with and substitute the value 1.45. If you're doing it as I've done here and used values of f of 1.45 and f dashed of 1.45, then make sure you use more than 3 decimal places, because our answer needs to be quoted to 3 decimal places, and that turns out to be 1.427 to 3 decimal places. 5 marks available in that part of the question. M1A1 for the differentiation, an A mark for getting the value of f dashed here correct. That might be implied if you've then got the correct answer. A method mark for the form of substituting the value of 1.45 into the form of the Newton-Raphson expression, and then a final answer mark at the end. So there are the total of 5 marks for that part of the question. Well, that's the end of that question. Other questions for this module and other modules can be found at www.furthermaths.org.uk.